Hi guys, and welcome back to Learn Extra Live. We are having such an awesome time, and there are so many questions coming on the page. We are getting to them probably in the last 15, 20 minutes of the show. We want to
Maybe we can take a couple now. Yeah, we can take a couple now, and then we can move on.
Bruce says now, and then we can move on. So let's have a look. So now I'm going to say, Moipone, she asks, open cast and shaft mining diagram. Is it important to know for exam purpose?
Put it this way, I don't think they're going to ask you to draw it, okay? But what they might do is they might give you two different pictures, okay? Like I've given you now, or sketch diagrams, and ask you to label which one's open cast mining, which one would represent shaft mining. But I don't think they're going to ask you any specifics. They're not going to ask you to draw it. I think they'll probably ask you to maybe to identify from pictures. That'll be my call.
Cool. Okay, so now this one is from Takalani. Takalani's always on the page, always answering questions and asking questions, which is awesome. And Takalani wants to know, what do we call the sediments where gold is extracted?
Sorry?
The sediments.
Well, basically gold is extracted through a type of quartz. Okay, so when we spoke about our mineral earlier, and that's our silicon dioxide, there's actually a type of quartz and a special type of quartz-bearing rock. Okay, so let me say that again. Gold-bearing rock, which is made up of quartz. Okay, so what the geologists do is that they track this particular type of rock. Okay, and they're able to follow it, and they call that they follow this path, and this path is called a seam. And as they follow the seam, and they're able to track it, then they're able to work out where it's going. And that's why often these mines have to go so deep, because sometimes the seams sort of shoot downwards, and therefore they've got to go deeper and deeper and deeper to go and extract the gold from that seam.
Cool. Okay, now this is a pretty cool question, and what the rad thing is that Takalani's actually answered this question, so thank you for helping Mindset. That's what we need to see on the page. So now this is from Abu, and Abu wants to know, why is gold so expensive and more expensive than, say, iron?
Okay, it's got to do with rarity at the end of the day. Iron is pretty common. Okay, it's one of the most abundant metals. Very useful metal, and that's what the Iron Age, if you go back a couple of thousand years, the Iron Age man was able to use iron to create weapons, to create cast iron pots and things like that. There were lots of uses for it. Gold is rare, okay? Plus, gold has also got a very beautiful look to it. And therefore, gold has been used as currency, as jewelry, as sort of a mark of wealth for thousands and thousands of years. So therefore, if we go way, way, way back, we know that if you go back, let's say, to the ancient Egyptians and things like that, gold was used very much as a symbol of wealth, as a symbol of currency. And therefore, basically, it got that iconic status because of its shininess. It's a beautiful looking metal, and also very easy to work with as well. So they were able to mold the gold into all sorts of shape, and that's why it was used extensively for jewelry. And that's where its wealth and its value sort of came from.
And what about the difference between platinum and gold?
Okay, platinum is a completely different element. Okay, if you look on the periodic table, you'll see that platinum has got the symbol PT, where gold has got the symbol, and I may as well put it up here, AU, where platinum is PT. Now, platinum is even more rare than gold, okay, and therefore it has got a much bigger monetary value. Again, look on the news on television, they always quote the platinum price as well, and generally, the platinum price is a fair amount of US dollars higher than the gold price because it's so much rarer. And another thing, while Indy's just told me about platinum and the questions come in, platinum is actually 50% of the world's platinum is actually found in South Africa. And that's why our platinum mines are very, very wealthy, very wealthy entities. They make a large amount of money, and because of the ability to sell platinum onwards to the rest of the world. And platinum is used in jewelry as well, okay? But it's probably pretty unaffordable in comparison to gold. If you had to go and buy platinum jewelry, way more expensive than it is with gold.
Okay, we've got more questions, and they're pretty good. Okay, so now Anela says, this one, I hope this is true. Probably not, but we'll see. Is it possible for gold to be found in the mantle and erupt in a volcano? out of a volcano.
Well, yeah. Well, basically, that's what they call alluvial gold. Yes, it actually is.
Oh, I want a
Because-
volcano like that near my house.
Well, yeah, you don't want a volcano going off next to your house. That's the big thing. But where does gold come from? It comes from the inner side, inside of the earth. And basically what happens is that, yes, it will be spewed up. Gold-bearing rock will be spewed up. And when that rock cools down and forms so these rocky outcrops, the gold is actually trapped inside. Now, that would have been done millions and millions and millions of years ago when the earth was being formed. So what would happen now is that with water, you get erosion. And with the water erosion, eventually the rock will get worn down, and the gold would then be extracted out of the rock. It would wash down in the rivers. And that's how they found the alluvial gold, the gold that's on the surface. And that's what originally the miners, or should we call it the prospectors, would go out there and pan for, would be this alluvial gold found in the rivers, because it will be washed down in the streams. Okay, so yes, it would come up from the inner parts of the earth. Okay, from the underneath the crust, and it would spew out, and it would be trapped in the rocks that will form as a result.
Okay, cool. What we're going to do, Mindset, is we're going to answer one more question and then keep those questions coming for Bruce. We're going to let Bruce move on with his lesson.
Okay.
But let's do it. So now this one's from Kelly, and Kelly asks, between the lithosphere and the hydrosphere, where do we find the majority of gold?
Yeah, basically the gold is found just basically in the Earth's crust, probably the first 5 to 10 kilometers in the Earth's crust. That's where the majority of gold is going to be found. Can we go down to those sort of depths of 10 kilometers? At this stage, probably not. Okay, I think that the pressures, the temperature, the heat that will be at the bottom of those mines would just be too much. Okay, so we are probably entering a phase where we could be pretty much at the limit of man being able to work under the conditions of those very, very deep mining shafts at around about 4.5 to 5 kilometers. So the majority of the gold that we are able to get will be found between 5 and 10 kilometers, or let's say from the Earth's surface down to about 10 kilometers underneath the Earth's surface itself. Is there going to be lots of gold that's going to be sort of on the surface? Well, yeah, if we're able to go deep into certain mountains that contain a specific type of gold-bearing rock, yes, you probably could find gold that's still going to be on the surface. And even today, they still find and develop new gold mines. And as they come across, and geologists are able to say, wow, I've just seen quite a lot of gold-bearing rock in this formation, they will go and try and excavate, and they will try and get the gold out, because gold is such a precious material. And the world bases its economy on gold. Everything revolves around gold.
Perfect.
Cool.
Okay, what we're going to do, guys, we're going to carry on with the lesson, but that doesn't mean that you need to stop sending your questions. Facebook.com/LearnExtra, or chat to me on Twitter @LearnExtra. Bruce, let's carry on.
Okay, guys, so what we're going to have a look at, we've spoken a lot about the gold mining. Now, I'm going to spend a little bit of time talking about how we process what we call the gold ore. Now, what I've introduced here is the term ore, and we speak about ore quite a bit, and you can speak about gold ore, you can speak about iron ore, you can speak about copper ore. But what do we mean by ore? And this is quite important, so I would take note of this. This is the volume of rock that contains minerals which make it valuable for mining. So when we talk about a certain amount of ore, we're talking about a certain volume of rock. Okay. Inside are going to be the trapped minerals. Okay. Is it going to be gold? Is it going to be iron? Is it going to be copper? Etc. etc. Okay, so we're going to talk about now gold ore. Okay, we mine it as gold ore, and then we're going to process it to extract the pure gold. Now, the important thing is that, excuse me, only a very small amount of gold is actually extracted for every ton of gold ore or ore that is mined. Okay, so it's quite a labor-intensive process. Okay, it requires vast amount of rock. Okay, which they're then able to crush, and they're able to get into a powder form. Then they've got to chemically extract the gold from the rock itself. But the amount of gold they actually get out is going to be very, very limited to the volume. And that is why when you look at gold mines and where they actually process all this rock, it's pretty large, pretty hectic sized equipment that they do have there. And all that rock that goes in, that's basically brought up from deep down from the mine shaft, is taken up you probably find they're only going to get a very small amount of gold out of it. So you can see now that the processing and extraction techniques have to be pretty good. Otherwise, how much is actually going to waste? And the questions that often get spoken about now is that if you look at modern mining practices compared to maybe mining practices 120 years ago, 120 years ago wasn't that great. So in the mine dumps where they throw the leftover gravel and sand that's after they've extracted the gold, how much of those old mine dumps, how much gold is actually left inside those old mine dumps? And they're actually even starting to re-mine those mine dumps to try and extract any gold that might have been missed from not such good techniques. But the important thing is that we're now going to have a look at that extraction process and the processing. And we call it gold cyanidation. Okay. In fact, let me pronounce it properly. Gold cyanidation. Okay. It involves using a cyanide compound. Okay. And the cyanide compound is what we have to use to extract the gold. Now, straight away, a lot of you guys should probably be jumping up and saying, well, cyanide, is that not very toxic? Absolutely. It is a lethal substance. Potassium cyanide, which they do use in this extraction process, is very, very toxic to the human body. So therefore, great amount of care has to be taken when it comes to this extraction process. And basically, we're going to have a look at this chemical process, and we're going to see now exactly how it does work. Well, as I said, guys, the ore is crushed. The rock that comes up has to be crushed, and they then use sodium cyanide. They can use potassium cyanide, but they do like to use sodium cyanide, and there's the chemical formula for sodium cyanide, NaCN. And what happens is that when we add the sodium cyanide solution, is that the gold particles are actually dissolved out of the ore. Okay, and if you have a look at the chemical equation, it's a rather nasty looking equation, but we'll break it down and just make sure that we understand it. So what we've got is the gold ore, okay, well the gold in the ore itself, okay. Now how do we pull it out? Well, we're going to use this chemical process. We can't go there and take out little bit by little bit, flake by flake. So they take the gold, they add the sodium cyanide in the presence of oxygen and water. And what it does, it forms this rather exotic looking compound. It's called sodium gold cyanide or cyanate. Okay, sodium gold cyanate. And can you see now that the gold has now been extracted from the ore itself and placed into this complex, this compound. Now, what we can then do is take this compound, this gold sodium cyanate, and we are able now to take that, and from there we're going to now pull the gold out of it. That's the process. So the step one, okay, very important in this extraction, is to now chemically pull the gold out of the ore, okay, and form this complex. And the important thing is that gold is actually oxidized. So if you now look at your redox chemistry, and at this stage, I think a lot of you guys would have done some basic redox and understood the concept of oxidation numbers. What we can do now is have a look and see what is happening now in terms of the movement of oxidation, the oxidation numbers, because we actually have a redox process on our hands. So let's have a look now, and I'm just going to change the color of the pen. So if we look at gold in its pure form, we can see now that the oxidation number of gold, or any element in its pure form, is 0. Okay, and if we come across here, let's have a look now. Well, if we look at sodium cyanide, sodium is always +1. Okay, therefore, the cyanide portion is going to be -1. So therefore, if we come over here, sodium is going to be +1. Cyanide is -1. There are two of them. It's -2. There's one sodium. It's +1. We must remember that the total oxidation number must add up to 0. And therefore, can we see now that we have got, must be +1. Yeah, there it is. So therefore, can you see, guys, that gold is actually in the +1 oxidation state. It has been oxidized. In other words, it has lost an electron. To form that compound that we're able to extract, we have to oxidize it, and we have now got it in the +1 oxidation state. So what do we now do after that? Well, the gold-bearing solution, so this here is going to be the gold-bearing solution. It's now separated. We separate it by filtration. Okay, so obviously the unreacted ore would stay behind. We filter it, so the filtrate that comes out now has now got the dissolved compound. And then what they do is that they add zinc to the filtrate, to the sodium gold cyanide complex. They add zinc powder. Okay, and what actually happens here is that the zinc reacts with this complex, and what it does, it displaces the gold out of the complex. So what happens now, where gold now is there as +1, can you see now it goes back to its original oxidation number of 0. So in other words, we have now got a reduction. Okay, we have actually reduced the gold, and we've now got it back into its pure form. So there, guys, is the extraction technique. Okay, the cyanide process, as they call it, and we are able now to pull the gold out the rock, put it into this cyanide complex, filter it, then take the cyanide complex, add zinc, and the gold comes out. And now they're able to extract pure gold out of that ore. And yeah, basically, it's an example of a redox reaction. Okay, and that, in a nutshell, is the chemical process of extracting gold from its ore. Now, what a lot of you might be worried about is, well, the question might come through, do I have to learn that equation? I would be very, very surprised if they make you learn that equation. Okay, I think if they're going to test you, they will probably test you by giving you the equation and asking you what is happening here. Okay, and the important bits of chemistry that you have to know, and in this section is probably the only real bit of chemistry that is that's important at this stage, is that we have got the oxidation of the gold in the ore to the formation of that sodium gold cyanide complex. Okay, and then they might ask you, well, then what happens? Well, then it's filtered, the filtrate is then taken. The filtrate over here, the sodium gold cyanide complex, reacted with zinc, and gold is then displaced by the zinc, and we have now got our pure gold, which we're now able to purify. And I think that basically is very simply the process of extraction. Now, what I'm going to make a little start about as well is that we've had a few questions about the value of gold and some of the uses of gold and stuff like that. What makes gold so important to us? Well, the first thing is that it's a beautiful metal. It's a beautiful, shiny metal, and the value of the gold is based on that shininess. Also, its rarity as well. So it has a beautiful appearance, and it's been used for jewelry, as also as a measure of wealth, for absolutely thousands of years. The other thing about it, it's durable. Now, what does that word durable mean? Durable simply means that it doesn't tarnish. It doesn't lose its color, okay? It doesn't lose its shininess or anything like that. So in other words, a piece of gold that's been around for 1,000 years would have looked exactly the same, whether we saw it 1,000 years ago or whether we saw it today. That gold remains a nice, beautiful, shiny piece of that yellowy orange metal. Okay, so it's a very durable substance, and it does not corrode. Okay, corrode means rusting. Now, if you think of our substances that do rust, iron, aluminium to an extent, but iron always rusts. You put iron in the presence of oxygen and water, it's going to rust, pretty much gets destroyed. And therefore, you can see now iron just does not have that ability to last. So again, this durability of gold allows it to, or gives it value, because it's now going to remain a beautiful piece of metal pretty much for your entire lifetime. And you will not have to go and polish it up or have to go and replace it because it's been eaten away by anything. And I think I'm going to take a break. I'll finish the rest of the the rest of the characteristics after the break, and then also take a few more questions.
I think that sounds like a brilliant idea, guys. So I think that we're actually ending, in 15 minutes, the show is nearly over. You know what that means? That means that you've got about 15 minutes to get those questions in, and we'll be going over as soon as we get back. Guys, see you now after the break.